Hello, my dear friends. Welcome to another lecture. In this lecture, we will see matrix multiplication. In our last lecture, we saw matrix notations. Now, in this part of this linear algebra, we will see matrix multiplication. In last lecture, we multiplied matrix with a vector. So we got our AX. So this was our matrix multiplication with a vector. Now we will see how to multiply two vectors. We will see how to multiply two matrices, that is A multiplied by another matrix B. The multiplication AB will be identical like the vector, like the matrix vector product that we have seen. So let us say that we need to multiply two matrices A and B, and let the columns of B be B1 and B2. So we can write B as this matrix B. So this B1 is nothing but a first column, B2 is nothing but the second column. Now how we can write AB? We can write it as A times B1, A times B2. So this is how you multiply a matrix. Now this was the column way. Similarly, we can do with the rows, but here the rows will be of A. So how we can write AB? So let us say the row 1 of AB R1 and row 2 of A matrix B R2. When you multiply this by matrix B, you will get it as R1 times B and R2 times B. So this is how you multiply with the column, and this is how you multiply with the rows. So each column of our matrix AB is the product of the matrix and the column. So our column J of our AB matrix will be nothing but A times the column J of B. Similarly, each row of AB, this will be a product of a row and the matrix B. So we can write row I of AB. This will be nothing but row I of A times the matrix B. Now the other way uh, is to get each entry of the matrix AB. So we will see how to get each entry of this matrix. Let me first clear this part. Now we will see how to do using each entry. Now each entry of the product AB is a product of a row and a column. So how do we say this? First AB at the value ij. So value ij of the matrix AB, this will be nothing but row I of A times column J of B. So we can write it as AB, that is the value at some ij. This will be nothing but A I1 B 1j plus A I2 B 2j, and similarly this will go on. Now we will see this using a 2 cross 2 matrix. Let this be AB, let this be equals to A11 A12 A21. Multiply this by another matrix B. Let this be 1 B11 so I think we are okay now. So this will be B11. Let me again this one note. So let us do this thing again. So this will be B11, B12, B21, and then B22. So using this above formula, let us see how to get each entries. So this will be, to get this A11 entry, this will be A11 times B11 plus A12 times B21. So you multiply this row with this column. So it will be A11 B11 plus A12 B21. Similarly, to get the value at 1 comma j2, you put I equals to 1, j equals to 2. So it will be A11 B12 plus A12 B22. A11 B12 plus A12 B22. Now you multiply, now we can get this entry and this entry. You multiply this row with this column to get the first entry, and then this row with this column to get the second entry. So this will be A21 B11 plus A22 B21. Similarly, our last value will be A21 B12 plus A22 B22. So we have our four values of the matrix, of the multiplied matrix. Now let us see some of the properties of this of the matrix multiplication. The first property is associative property. So what do you mean by associative property is that if you multiply AB and then multiply C, this will be same as multiplying A to the matrix BC. The second property is that it is not commutative. So AB might not be equals to BA. It may happen, but generally AB is not equals to BA. Our third property is that multiplication is matrix operations are distributive. That is A times B plus C. This will be equals to AB plus AC. So we will use these properties in our upcoming lectures. Now for the rest of the lectures, we will solve two of the problems. Now one more property in matrix multiplication is that if you multiply two matrices A and B, suppose that this is M cross N matrix, that A is M cross N matrix, then B has so this means that A has M rows and N columns. So B matrix should have N rows and it can have any number of columns, let us say M and R. So The number of columns of A should match the number of rows of B. The final matrix that after multiplying this AB will be of the form M cross R. Let us see this using an example. Let us take a 3 cross 2 matrix. So let it be 1 2 1 3 2 5. So this is a 3 cross 2 matrix. Now you can multiply it with a 2 cross 2 matrix. So let us say 1 2 3 4. So this is a 3 cross 2 matrix. This is a 2 cross 2 matrix. Our final matrix will be a 3 cross 2 matrix. So let us multiply it. So it will be 1 times 1 plus 2 times 3. So it will be 1 plus 6. Second entry will be 1 times 2 plus 2 times 4. So it will be 2 plus 8. Third entry will be 1 times 1 plus 3 times 3. 1 plus 9. Other entry will be 1 times 2 plus 3 times 4. So this will be 2 plus 4 times 3 is 12. So this will be 1 times 2 plus 5 times 3. So 2 plus 15. Our last entry will be 2 times 2 plus 5 times 4. 4 plus 20. So this will be a 3 cross 2 matrix. Now let us see an interesting question of this matrix multiplication. So we are given a theta matrix, that is A is in the form of theta. So we are given that first entry is cos theta, second entry is minus sin theta. C symbolizes cos and S symbolizes sin. Third entry is again sin theta, and fourth entry is cos theta. Now we need to verify that A theta 1 matrix when multiplied by A theta 2 matrix, this gives us A theta 1 plus theta 2 matrix. So we will multiply two matrix. First we'll have theta as theta 1, second we'll have theta as theta 2. So let us multiply those two matrices. So A theta 1 times A theta 2. So this will be C theta 1 minus S theta 1. This is S theta 1. This is C theta 1. We multiply this by theta 2 matrix. So this will be C theta 2 minus S theta 2. This will be S theta 2 and C theta 2. We multiply these two matrices. We will get C theta 1, C theta 2. Our first entry will be C theta 1, C theta 2 minus S theta 1, S theta 2. Our second entry will be C theta 1, S theta 2, S theta 1, C theta 2. You can take, so this will be minus C theta 1, S theta 2 minus S theta 1, C theta 2. Third entry will be S theta 1, C theta 2 plus C theta 1, S theta 2. This will be S theta 1, C theta 2 plus C theta 1, S theta 2. Last entry will be minus S theta 1, S theta 2 plus C theta 1, C theta 2. So now we can just apply our properties of this matrices. So let me clear this portion. So this C theta cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, this is nothing but cos theta 1 plus theta 2. Similarly, this will be minus sine theta 1 plus theta 2. This will be plus sine theta 1 plus theta 2, and this will be again cosine theta 1 plus theta 2. So this matrix is nothing but A of theta 1 plus theta 2. So we have verified that for this matrix A theta 1 A theta 2, this will be equals to A of theta 1 plus theta 2. So I hope you have got how to do matrix multiplication. In our next lecture, we will see how to divide matrix into two parts, lower triangular and upper triangular matrix, and into three parts, A equals to LDU. One will be lower triangular, U will be upper triangular, and D will be the diagonal matrix. So that is all in this lecture. I hope to see you in the next lecture, which will be an interesting part. So that is all in this lecture. Thank you for watching.